All right, so for our last chi-squared hypothesis test that we're going to be working on today, we want to work on the test for homogeneity. So setup-wise, this is going to be similar to our independent-dependent test in the sense that it's kind of a multi-variable situation where we're going to have a matrix. But in terms of what we're actually trying to figure out, we're trying to see if this is a goodness of fit test. So we're trying to see whether two distributions are similar to each other. So this is kind of testing what our goodness of fit test did back in the first section that we talked about, but applied to a multi-variable situation. So the good thing is when we look at our different setup for our test for homogeneity, then in this case, instead of having as many possible rows as we want, we're always going to be comparing just two things at a time. So it could be like SAT scores and ATC scores. It could be like pre-test and post-test. So our rows are always going to be two in this case. So our number of rows are always going to be two. So even though we're going to have a column of information, our rows are always going to be two. So because of that, when it comes to finding our degrees of freedom, it's just going to be our columns minus 1 because it's all of our rows are 2. When I do 2 minus 1, I'm just going to get 1, which is basically the same setup we were in the previous section. All right, so our hypotheses, so again, these are going to always be the same regardless of what test, or as long as we're doing homogeneity. So our distribution of the two populations are the same is going to be our null hypothesis, or the distribution of the two populations are not the same, which is going to be our alternate hypothesis, and that's also what our claim is going to be. So again, since this is in a matrix form, when it comes time to find our chi-squared sub t, this is going to be exactly what we did in the last section. So L1 minus L2 squared, all divided by L2. Our chi-squared sub c, we're going to use the table for. And then again, our p-value, exactly the same as what we've been doing. And then finally, when it comes time to draw our conclusion, the p is less than alpha, we reject the null hypothesis. The distribution of the two populations are not the same. If p is greater than alpha, we fail to reject the null hypothesis. There's no evidence that the distribution of the two populations are the same. All right, so again, let's go ahead and dive in since we've already did one similar to this in the last section. So again, we're going to have our observed matrix, our expected matrix, all that kind of stuff. So everything about our multi-variable is still true. So with this one, we've got our observed matrix is what happened to our different high school graduating seniors to see what they do after school. So what we've done is we've compared two different years, 2010 to 2020, just to see if there's a difference in the distribution. So our possible choices were they could go to college or some post-high school education. They could go straight into the workforce, they could go into the military, or they could take like a gap year and go and travel. So we've got all of our observed matrix laid out. So if we want to go ahead and state our hypotheses, so in this case, the two distributions are different, is what we're trying to show, but the same would be the null hypothesis for this one. And so let's go ahead and set up our expected matrix real quick. And so we've got, so I'm going to list the first one as college, post-high school just listed as C, employment, military, or travel. And so apparently I added an extra column again, which I didn't need. And then over here we've got, oops, I did need it. I just started in the wrong spot. My bad. So let me extend it this way. All right, there we go. So we've got our 2010, 2020. And so again, just like we did before, to figure out what these different positions are, I'm going to take this row total times this column total divided by the 605. So I'm going to get 290 times 533 all divided by 605. And that's what's going to go in this first position here. So again, I'm going to write out the whole chart. I'm going to have you try the expected value matrix on your own. And if you have any questions or anything like that, just let me know. So this should be 255.5, 19.7, 11.5, 3.36, 277.51, 21.35, 12.4, and 3.64. So again, I'm going to stop the video at this point, give everybody a chance to figure out this expected matrix on their own. If you have any questions or anything, let me know. If you get the same thing, then jump on to the next video and go from there. So good luck.